Hi parents, welcome back. The next few videos that we're going to do together are going to focus on the importance of fact fluency or number fluency. Now there's a lot of misconception out there about what it means to be fluent in math. Most of us grew up in a time when you had to memorize your facts, and it was all about doing flashcards or sitting at the table like I did at the kitchen table trying to remember all my multiplication facts or all my addition facts and getting frustrated. Many of you were probably really good at that. Many of you, like I did, probably took timed tests to see how fluent you were with your facts. You see upper grade teachers who are so afraid that kids don't know their facts, and that slows them down with their the higher level mathematics. You see parents saying, oh, I'm really fearful that my child doesn't know his facts yet. There's a lot of misconception out there about what it means to know math facts. So I want to talk a little bit about what that means. And instead of calling it knowing their basic facts, I want to talk about it in terms of mathematics fluency. The National Council of Teachers of Mathematics defines fluency as being more than memorizing facts or procedures. It's about understanding and being able to use a procedure at a given time because you understand the concepts behind it. So knowing when to add or knowing when to subtract and so forth. But when you get down to just really basic facts in terms of those addition facts or subtraction facts, it starts with conceptual knowledge. NCTM is very adamant about the fact that you have to build those relationships and you have to have kids understand what's going on in addition and subtraction and multiplication and division before you have them become fluent in them. Kids go through a predictable sequence in becoming masterful with numbers or masterful with facts. They start with just counting strategies because that is the most basic way to find out an answer to a problem from anywhere from 3 plus 5 to 38 plus 25. In those early stages, kids will count each one to find an answer, and that works. It's just not the most efficient strategy. As they get better with the numbers and build on that number sense, they start to use relationships, as I said a moment ago. They start to derive facts. So they use known facts to help them with unknown facts. They use properties of numbers and relationships of numbers to help them determine an addition or a subtraction or a multiplication or a division solution. And then at some point, we really want them to get to that masterful stage where they just can come to an answer very quickly, that they can produce the answer 10 times 10 is 100 without having to think about it anymore. But they can't skip those earlier stages. They really have to build on what they understand about counting and then build on what they understand about sets and groups and then move to that mastery stage.
Let's take a look at some of the prior learning that kids have to have under their belt before they can really move towards mastery in facts. They have to be able to orally count, obviously. That's one of the earliest things we talked about in one of our earlier videos. They have to have one-to-one correspondence. They have to understand that when they count items, that they have to tag with them, and each number counts as another one of those items. They have to understand number as a quantity. We talked about that before in one of the earlier videos, that understanding that 7 is made up of 6 and 1, and also 5 and 2, and also 4 and 3, and that 7 has a value. It's not just a cardinal number or the 7th one in a series, but it actually is multiple smaller sets of numbers. So we talked about that in terms of counting things like these dots here. For our youngest kids, sometimes that just means tagging. So calling them 1, 2, 3, 4 would be like naming them names. And if I said which one is Sue, I would point to the one that has Sue under it. So at that point, kids don't necessarily understand number as quantity. When they understand number as quantity, they see that numbers are nested within numbers, that smaller sets are nested within smaller sets. Then they start to understand 5 and 10 as anchors, which we talked about in some of our early number sense videos, that we really want to build on that sense of 5-ness and 10-ness. And then they start to really dig into that part, whole kinds of relationships of composing and decomposing numbers. So taking apart that number 8, that 8 can be made up of 8 and no more, 8 and 0, or it can be 7 and 1, or it can be 6 and 2, or it can be 5 and 3, and so forth. Or it can be multiple sets like 2 and 2 and 2 and 2. Then they start to really dig into the understanding of equal sets when they get into multiplication and division. So they start with what we call unitary thinking. They see lots of things and they count lots of things. Once they have one-to-one correspondence, they count each one of those dots. They have different ways of doing that. When they're not efficient counters, sometimes they will count the same one over and over. As they get better, they might tag them, they might mark them out, but they still see all of those items as being one and one more and one more. As they get better with number and number sense, they start to think about numbers and sets. That's how our base 10 system is built on. So for example, I can think about all of those dots as being sets of 10 and some more. So here I have 1, 2, 3, 4, 5 sets of 10, which is 53. I also have 53 there, but you can see this is a more efficient way of thinking about it as they start to make sense of how numbers are related and they start to understand our base 10 system. And then they start to think about equivalency a little bit better. So I can take those sets of 10, those 5 sets of 10, and I can unpack some of those sets of 10, and I have 3 sets of 10 and 23 ones, but that's still equivalent to that 53 that I started with. So I can pack and unpack numbers and group and ungroup numbers to really build on that base 10 system, in which we really need kids to have that foundation in order to do addition and subtraction and multiplication and division with those higher numbers.
In the next few videos, we're going to spend some time really delving into how we can help kids have fun while they're also mastering those basic facts, and how they're becoming more fluent and more flexible with their understanding of numbers and number sense. And one of the best ways to do that is just through games. Games are one of the ways kids can apply their understanding, but also build an understanding. So thanks for joining me today, and I hope you'll spend some time taking a look at some of the ideas that I'm going to share on how kids can become more fluent with their math facts. See you next time.